Hello everyone, my name is Aditya Yadav and today I will be presenting my project titled IoT Based Home Automation using Arduino PicsimLab and a Blynk Application. This project is part of the Emertxe IoT training module. My- and it will demonstrate how IoT technology can be used to build a fully automated and remotely controlled home environment. All simulated using PicsimLab and managed through the Blynk IoT platform. In this session, I will walk you through the project purpose, scope system requirements, working modules, user interface, and final conclusion. This is the title for our project, IoT Based Home Automation Solution prepared by Aditya Yadav. You can hear this. Now, talk about the overview. The main purpose of this project is to understand and implement an IoT-based home automation system. The main purpose क्या है? Home automation using Arduino and Blynk application. This documentation and presentation serve as a guide to the system requirement, design principle, and expected functionality. The ultimate goal is to demonstrate how multiple home systems such as lighting, temperature control, and water level monitoring can be integrated into a single smart IoT framework. This project is designed for a simulation, meaning all the peripheral and sensors are implemented virtually within the PicsimLab environment, providing a safe and accessible platform for development. Here we didn't use a physical device, just we will we have developed we have simulation virtually within the PicsimLab environment पे हुआ है. Now talking the scope of scope this project covers the simulation and control of three key home subsystems. First, lightning control. I will tell you lightning control, temperature regulation, water management. First, lightning control, which automatically adjusts light intensity based on environmental brightness. As you can see that here, control light temperature and water flow in the tank. Second, the temperature regulation, which uses sensor and actuator to maintain the desired room temperature. And the third one is water management, where inlet and outlet valve are monitored and controlled automatically based on the tank water level. All of these systems are monitored and controlled view the Blynk IoT mobile app, which serves as the remote user interface. रिमोटली एक्सेस करने के लिए हम यहाँ पे ब्लिंक IoT एप्लीकेशन का यूज करेंगे ताकि all the project operate under few assumption and dependency and constraint. The Let's talk about assumptions. First, all peripheral are simulated component within PicsimLab. No physical hardware is connected. Yet there is all simulated. No real-time physical device or interface. Second, the depend on the Blynk cloud and mobile application for remote control control and data visualization. Remote control and third one is lastly the project is simulation based. There are no physical constraints such as power consumption or device level. These assumptions make the project ideal for learning and validating IoT concepts before deploying them on real hardware. Here you can see that the system rely only on the user interaction and control. You can see here assumption where it's immediate dependency depend on Blynk mobile application for control and monitoring constant non-specified. Now the system has been divided into three major functional modules, such each representing a real-world home automation figure. The first one is garden light control system, second one is temperature control system, and third one is water tank control system. You can see that garden light temperature. The garden light control system automated lighting based on sunlight detection, temperature control system monitor and manage indoor temperature. The water tank control system managing water inflow and outflow through automated valve. Let's now go through each module in detail. Garden light control. You can see the requirement. This is a functional requirement how we will develop IoT based home automation, smart home के लिए. Here, the garden light control system uses an LDR sensor. This one is using LDR sensor. Based on the reading from LDR, detect the ambient light intensity. The Arduino reads the sensor value using the analog to digital ADC, digital converter. Arduino reads the sensor value using the analog to digital converter. Yeah, how Arduino Uno read data from LDR sensor using ADC, analog to digital converter. Based on the LDR reading, the system automatically adjusts the brightness of an LED, which represents the garden light. Based on the data they have get from LDR sensor, now Arduino Uno control the light. It will on this one. Arduino Uno will control the light. For this project, what we need LDR sensor input. We just need LDR sensor and the light. Process read the LDR sensor value on the reading from LDR. Vary the brightness of the LED, which resemble control garden. When जैसे let's explain in briefly. Based on the LDR reading, the system automatically adjusts the brightness of LED, which represent the garden light. During daytime, when sunlight is sufficient, the LED remain off. In the second, as the light intensity decreases in the evening, the LED turn on, gradually turn on, simulating how garden light responds naturally to sunset. This demonstrates an energy-efficient lighting control system. This is how we can uh, make this automatically control using even. The second one is temperature control system. In the temperature control system form the second major subsystem. It includes an LM35 temperature sensor, heater, and a cooler, all controlled through the Arduino. What control? First Arduino, no? Control what? You can see here LM35 sensor. Second one is IoT mobile. ये तो control उनमें से होगा. It will control through the IoT. Heater, cooler. Let's talk about it. Here is LDR sensor. It's the brief. A temperature control sensor. What component require LM35 temperature sensor, cooler, and CLCD display. Here you can see the CLCD temperature system. ये LM35 sensor होगा. And talking about the process, how it will process. The LM35 sensor provide analog voltage proportional to the temperature. Arduino read the value, convert it to degree Celsius. What it will do? Arduino read the temperature from this. Read the temperature from the temperature system. In LM35 from LM35 sensor, and it convert to degree Celsius and display it both on, or where it will display on this display and here. Okay. Blynk app. In this Blynk app, user can manually control the heater and cooler using dedicated button. The mimic a smartphone HVAC system where the temperature can be adjusted remotely from a smartphone. What is let's briefly we can hear temperature system what we require. Temperature sensor we need, process read temperature from a temperature. We can see. Now third one is requirement cooler control system.